Welcome everyone, my name is Tim Burris and today I want to talk about hosted services in .NET Core. So what are hosted services in .NET Core? Well, hosted services are a way that you can have background services running or services just listening, waiting for events, and they're hooked into the .NET Core framework. So you don't need to create a Windows service. This could be an ASP.NET Core service. Maybe it's in your web application or your API application or your console application. But the idea being there's a framework already built for you to build services that are always running or listening in the background, performing tasks. So let me set up the scenario that I most recently used hosted services for, and it demonstrates a number of different ways to use hosted services, which is why I'm going to use this example. Recently I had to develop an application for a client. It was a web application, a web API. So we're using .NET Core. So I had a web API. In that web API was a SignalR hub. So if you're not familiar with SignalR, we're not going to get into the details of SignalR in this demo, but SignalR is a way that you can have a live connection from your server to a client, and that client could be a web browser, could be a mobile app, could be a desktop app, could be another API. So a live connection between two endpoints where they can communicate back and forth. So what needed to happen in this application is when a very special notification came in to SignalR, SignalR needed to do, the application needed to do a couple of things. One thing it needed to do was it needed to send an SMS message. So a text message to predefined users that this notification has happened. So that's one thing that needs to be done. And I used Twilio for this. It really doesn't matter, but Twilio is a super popular, super easy to use SMS service. So when this notification was received, we wanted to send an SMS message via Twilio, and we also wanted to write the event to the database. So these two separate things, among other things, of course, but simplifying, these two things needed to happen when we received this message from SignalR. Along with that, hosted services would be a great way for both of these. So SignalR is running, the message comes in, SignalR will raise an event. Let's see if I can draw a beautiful event lightning bolt. Oh, come on. Yes, beautiful. So SignalR will raise an event, and a hosted service for SMS will respond to that event and send a Twilio message, and a separate hosted service will respond to that event and write the pertinent information to the database. In conjunction with all of this, so if you're familiar with Twilio, when you send us an SMS message to Twilio, all you do is post the message and you don't get a response immediately about whether or not the message has been sent. So we need another service that is going to be a polling or a background service that is going to constantly check to see the status of that Twilio message. Did it successfully send or did it not successfully send? So we will create a service that will check Twilio status. And this guy will always be running, and maybe every 5 seconds checking to see if there are any Twilio messages that we need to update the status for. So again, in quick summary, a message comes into Twilio. Again, in quick summary, message comes into SignalR. SignalR raises these two events. SMS is sent via Twilio, and it's logged to the database. And then in the background, all the time is this guy, the timer here, that is running to check to see if Twilio has any updated statuses for us. To say that message XYZ either failed to send or successfully sent. So that's what we're going to do. And now we will jump over to .NET and see how it works using hosted services. So what I have here is a completely blank, right out of the box, web API project in .NET Core. So this is the template. If you start a new web API, this is what you get. You get the old weather forecast. And the very first thing that I'm going to do in this project, if you watch my video on logging, you'll know the very first thing that I'm going to do is I'm going to add logging. So it's a .NET Core. I'm not going to use Serialog or Nlog. I'm just going to go straight and use Seek. So Seek has an extension that plugs right into Microsoft extensions. I believe it's Seek.extensions. And Seek extensions logging. This will let us get logging directly to Seek. And we can use this to do our testing and see that we're getting the events that we want to get and everything. So I'm just going to add that package. I'm going to go to my startup. I'm going to go ahead and add it in here. So we'll do builder services dot add logging or localization, add logging, and then we can do add Seek because we have that package installed. Now that we have Seek, we just need to configure it. So we'll hop over to our app settings. Again, this is part of what the extension gives you by default. So we'll come to the logging section in our app settings. We will just add a Seek section. And the only thing we need is the server URL. So we'll put the URL to where our logger is, which is right here on this machine. Default port. So that way all of our logs will go there, and then we can watch our app fire its events, and we can verify that our services are all doing what they're supposed to do. So we'll go ahead and fire this application off, and then we'll open Seek and make sure that our logging is working to start. So fire the application, open Seek, and yep, we can, sure enough, we see some message coming in from our hosted service. So we know that our logger is working. That's good. So now we can move forward with actually writing the code. And since the purpose of this demo is not SignalR, we're not going to wire up SignalR. We're just going to create a controller with an endpoint, and we'll use this guy to simulate our notification event, our input that comes through that needs to kick off our services. So we're just going to create a new controller. We'll call it notification controller, and we'll put just one post action on here. With our notification. So we'll post a message here, and anytime we get this post, we are going to kick off our events as if SignalR received its very important notification. So let's just go ahead and switch this guy over to be an actual API controller in controller base, and we'll just let the route be the controller. Okay, great. So we have our post action, and when we receive our post, we'll just return no content. So we'll say everything was good, but nothing to return. Good, and I'm going to switch this to the new namespace logic where we don't have those extra brackets, or extra braces, I should say. And we should see this guy working. Okay, so yeah, we see our new notification. We will test it out. It just accepts one value, which is a string. We'll just execute it, and we should get our 204. Yep. So that's good. We have our controller working. Let's just go ahead and bring our logger in just so that we can log when those messages are coming in. So we'll set up our logger using Microsoft extensions, and it will be notification controller. Okay, logger. So we'll just inject this guy in. We will, anytime we get this post, we're just going to log that that we received this message. So let's go with message received. And let's change this. Let's not interpolate this. Let's make this a parameter. So we're going to say message received, and we will let message be a named parameter, and then for arguments we will pass in the message. Just for clarity, I'm going to name this MSG so it's not confused with the message parameter up there, because while they might have had the same name, they're not the same. So we'll say we're going to create a new anonymous object with a property called message, or MSG, and its value will be equal to message. So now when we log this, we should see this message come in with the message in there, and this will also be a parameter that our logs can filter on or search on. Let's just make sure that all that is working. So we'll run this guy. We'll pull up our seek. We have our seek running in auto refresh, so anytime a message comes in, it'll automatically pop up over here. So let's go to our notification, try it out, and our string will be, this is a test. We will execute it, and of course see that it did not log. Let's see what happened here. Oh, we actually got a 400. Oh, yeah. Since we're not using a model and we're just passing a string in, we're going to have to put quotes around our text. So now we hit execute, and we get our 204. We also saw our message pop up over here. So we got message received. This is a test, and because we used that parameter, we can actually see that it created a property called MSG with the value. So we could actually filter on this, if we wanted to find all the MSGs that come in. So anyway, logging not the purpose of this video, but I can't help but show it off anytime I can. Great. So we have our messages coming in. Now let's go ahead and set up our fake SignalR. Since we're not really going to do SignalR, we are just going to set up kind of a mock. So we'll create a folder for our SignalR stuff. So .NET Core has a NuGet package for SignalR. You would just install that, and you would set up your chat hub. You would set up your hub, which is a service that will handle all the work of sending and receiving SignalR messages. So we're just going to kind of mock that. So we're just going to create our mock hub here. And in this hub, all we are going to do is we're going to define an event, which is not going to, we're just going to have a normal event handler, event handler, and we will say that this is very important event, very important notification, and we'll leave it at that. And we will put a method on here that will allow us to invoke it from our controller. If this were our SignalR hub, it would be waiting on a specific message to come in from SignalR. But for us, we are just going to allow a method that invokes it. So notify. We'll just create a method called notify. And when this happens, we will simply invoke our very important notification. Of course, there may not be any listeners, so we'll use question mark to do our null check. The first parameter is who's sending it. That'll be this object, and we don't have any event args, so we're just going to use event args empty. We'll just tab to autocomplete that. Now whenever the message comes in, we can easily call notify and notify everyone, which will be our SMS and our database logger. So we will save that. I'm not going to create an interface and all that for this demo. We are just going to go over to our controller. We're going to inject it just like it is. So we have SignalR.mockHub. We're just going to inject the class just like that, which of course we need to switch over to our program and register it. So we will builder services, not add MVC. Register, add singleton. So for SignalR, it would be one hub that is running all the time. So we are going to go ahead and register this as a singleton. So we are going to register signal. This will be hosted notification demo.signal.api, SignalR, mock-hub, and now that we register that as a SignalR, we can switch back to our controller. Now that we have it, after we log the information, we will use our mock-hub and we will say notify. So that's the method that we created that's going to raise the event. Let's go into our mock-hub and let's add logging here as well so that we can know that we received that message. Alright, injected our logger. So now when we receive it, we'll say log information, and we'll say let's just say notify was called. Boom. Now we should be able to see our mock hub log a message anytime we get our post. Fire these guys up. Come invoke our controller, and we see our message and notify was called. So we know that we're making it all the way through. We know that our service is registered and working. Now that we have our hub working, now it's time to actually write our hosted services. So again, we are going to need two hosted services, three in fact. We need one of them to tell Twilio to send a text message. We need one of them to log to the database, and then we need a separate one running in the background, always polling to see if there are any SMS updates. We are going to put our hosted services into a separate folder, and we will go ahead and add our first hosted service. This will be the SMS notifier hosted service. Now, to create this hosted service, it's very, very simple to create a basic hosted service. I'm going to switch this to the namespace per file. And to do it, all we have to do is implement hosted service, iHosted service. That interface provided by .NET Core. We will go ahead and implement the interface, and there are only two methods we need to worry about. One of them is start, and that will fire whenever whenever the service starts up, and stop will fire whenever the .NET Core engine is shutting down. So since this is our SMS notifier that wants to send a message to Twilio, we're going to need to inject in our hub, because what it's going to be watching for is it's going to be watching for messages, events, I should say, from our mock hub. And I believe I put that into a SignalR, SignalR mock hub. So we are just going to inject this little guy in here. So we have mock hub, and that whenever our service stops, whenever our service starts, we are going to hook up an event handler So very important notification is the event we're going to be watching for, and we are going to just create our event handler, and there's no async needed here, so we will just return task completed. And in our notification, this is where we would go and send to Twilio. We'd get our message and we'd send it over to Twilio. We're not going to implement Twilio, so as you can imagine, we are just going to log it. So we will inject our logger in for our service. Control dot to bring up the quick. All right, assign. All right, so we have our logger in here, and whenever we get this, we are going to log our information that SMS was sent to Twilio or whatever service. And that's all we'll do there. And then for stop, we are just going to we're just going to unhook our event handler, even though everything's going to be stopping. Probably not going to matter, but just for clarity, we're going to unhook our event handler whenever the service stops, and we will return that the task is completed. Good. Okay, so our first hosted service is written. Now all we have to do is hook it into the .NET Core stack. So we are going to switch back over to our program class, and we will just builder.services.add hosted service. And the hosted service we want to add is hosted service demo API hosted services SMS. Okay, so now we've hooked our service up, and if everything is working, when we run it, when we post our message, we should see our SMS handler there, which will be running in the background, just chilling, waiting for events. We should see it log the message every time. So let's run it and see what happens. All right, and we'll pull up our logging. We still have auto refresh. Now when we come and try out our message, we're going to just leave string. We should see it go all the way through. Great. So we received our message at the controller, notify was called in our hub, and our service that's running, our hosted service that's running in the background, always listening for events, received its message. So that's pretty easy. Next up would be logging into the database, and honestly, it's going to be exactly the same. So I'm just going to copy and paste this guy. And change its name. So this will be, instead of SMS notifier, this will be notification persister. A great name, persister. Oops. So that's what we'll call this, and this is the one that's going to be responsible for persisting these notifications, aka writing them to a database. So I've got that. I just need to change the file name. So control dot and say change the file to be this guy. Good. I fixed my controller name, fixed my logger just so that it's all logging correctly. And the same things need to happen for this guy, except for the only difference is this one will be writing to the database. Now, if you are wondering, wait, couldn't you just do all of this inside of MockHub? When you get notify, couldn't you just invoke your SMS service and say send message, and couldn't you invoke your repository layer, your data layer, invoke your repository and log it? Yes, but you don't want to. You shouldn't want to tightly couple those different pieces. The fact that they need to be written to a database, completely independent of what SignalR needs to do in his life. The fact that we want to send a Twilio message, completely independent of what the database wants in his life, nor what the SignalR wants. So the idea is you should separate those services out. How they act, when they respond, completely independent of one another. So that's why I recommend that we create separate services for each of these. I'm not sure why this guy's happy. I think he's just unhappy because we haven't recompiled. Yeah. Now I have added my persistent handler, and we just need to wire him up just like we did for SMS. Simple. Notification. So now when we run this application, we'll rebuild, run, switch over to our Swagger and our logging, and we will send a notification, try it out, execute. We should see it come in. Oh, I turned off auto. Oh well. I turned auto refresh back on, and we see that we did receive our message. So we received our message, notify was called, it was sent to Twilio, and it was written to the database. So now we have completely independent services responsible for responding to events so that each one of them can do what they need to do without impact on the other. Those services are running in the background, and we don't need to do anything. When the service shuts down, when .NET Core API shuts down, those services will just unhook their handlers and be done. So now there was one more service. So these two services are different than the third service. These two are just sitting idle. They're not doing anything. They're waiting for an event to fire to tell them to do some work. But our third service is more of a polling service. It's running in the background, and every 5 seconds it needs to go to Twilio and say, hey man, do you have an update on that message I tried to send? And that's the service we're going to write right now. So it's still going to be a hosted service, but it will be a little bit different. We will add a new class, and we will name this the SMS status updater hosted service. And what's different about this service is instead of implementing iHosted service, like we're going to implement background service. Now this is a wrapper that the .NET Core framework is providing for us. It implements hosted service itself, but it gives us a little more functionality than we get from just implementing it ourselves. So we'll derive from background service. There are some things we need to implement. It is an abstract class. And what we need to implement is the execute. Now, we can override start and stop if we wanted, but the way a background service works is it's going to start, and then when everything is ready, it's going to call execute. And that's when our code is going to be invoked, and we are just going to continue executing until they ask us to cancel, and they'll ask us to cancel via this cancellation token. So I'll show you how I like to implement this background service. We could just run our execute, and then when we were done, we could return task completed. The problem is, .NET Core is only going to run this one time. It's going to run it at startup, and then it's going to call execute, and then we're going to be done, and we won't have checked our database. We won't have checked our service. What we need to do is have this guy stay running and keep polling. So first and foremost, let's bring our logger in so that we can see what's happening. So we'll bring iLogger of our class, control dot, Microsoft Thinks, there we go. So now we've injected our logger in. First thing is we will go ahead and log when the execute happens. So we'll log the execute was called, and we will log when execute is complete. And this middle section is where we would do our work. So this is where we would check Twilio. And when we execute this, we're going to see that it only fires once. because .NET Core is just going to fire a service and then be done with it. But we will go ahead and demonstrate that just to see. So go back over to our program, and we will register another service. This will be our SMS status update service. All right, got that guy in the pipeline. We will run our application, switch over, pull up our logging, and already we can see that our service was called when we started up. So this time frame, this entry where we were written to the database was a previous call. You can see it was 4 minutes ago. So this is where our hosted service started, and it called execute. It immediately checked Twilio and execute complete, and no matter what we do, it's never going to fire again. So that's obviously not what we want. You know, we can do these guys, and we can see that this stuff keeps happening as we execute, but we will not get any more calls into our execute. Now that we know that our hosted service is at least firing up, what we want is for this to be a polling service, like we would expect our background service to be. To make that happen, inside of our execute, we're going to add a while loop. So we will say while we have not, while this the underlying framework has not canceled us, you know, while we are not requested to be canceled, we will do this. Of course, this right here means you know, this is going to be running as fast as the processor can go, like every millisecond, you know, or less than that. You know, we are going to get a log to Twilio. So we do want to idle this. I mean, we do want to throttle this a little bit. To do that, what we're going to do is we're just going to use the old school await, task delay, I should say. So we are going to await a task delay. If you notice, I do like some of the new features of Visual Studio. I think this is new in 2022. I don't recall it happening in 2019, but because I typed await, Visual Studio automatically went ahead and added our async decorator up here. So we will do our task.delay, and I believe we said we were going to do 5 seconds. So I'm going to do, I guess I could just put 5,000 in. I think everyone knows that those are milliseconds. I could go ahead and name my parameter so that it's more clear that that's, if I could spell the word delay, so that it's more clear that we're talking about milliseconds. But for me, I mean, honestly, I prefer just to use the time span to have a bunch of really great extensions off of them. So I can just say time span from seconds 5. To me, this is very clear what I'm expecting out of this call. But you know, everyone has their own preferences. Alrighty, and since we have now switched to an async method, well, we have await, and we've decorated, we no longer need to do our return. So now what we should expect is we should expect this logger to go out and check Twilio for updates every 5 seconds, and this should stay running the entire time that our web application is running. So let's see. We're going to fire it up. We will switch over to our logger. And of course, we're not invoking anything yet, but we do see that our check Twilio is just polling in the background. And that should just continue to happen. And so the value of that is when we send messages, when we try these this guy out and we post these messages that would cause Twilio, you know, a Newton text message to be sent to Twilio, boom, right there on that next iteration, we would check Twilio for updates. Now, how do you know which messages you need to check? Well, I mean, that's up to you. You have to figure out, well, how do you know which Twilio messages you have a status for and you don't? Maybe you're logging them to the database. Maybe you're storing them, in some kind of cache. That's up to you. The point of this is you now have 3 services. These 3 services here, 2 of them that are just chilling, just listening, waiting for things to happen, doing nothing until something happens. So that guy and this guy here, both are just waiting waiting for a signal that they need to do something. And then your third service is one that's running every 5 seconds to check the status. So I'm going to close the host down. So when I close the host, what I expect to happen is, because we have not gotten our execute complete because we're stuck in this loop. So when we close this host, this method should get a cancel request, and that should cause us to bail out of our while loop, and then cause our final log message to get written. So I'm going to pull this guy up. I'm also going to pull the logger up beside it so that we can see. We're still checking Twilio. Let's make sure. Yep, still checking Twilio. So I'm going to tell this guy to close. So it's shutting down, and we saw it. So .NET Core said, hey, we're shutting down, and our hosted service received the cancellation request and and closed up shop and finished. And that's exactly what we were hoping would happen. Could you accomplish this in other ways? Absolutely. You could have just created singletons here. You could, after your app starts here, you have your service host. You could in theory just go ahead and say my SMS notifier. You could notifier app.services.get service. You could go out and get your service. If this were not a hosted service, you could just create an instance of it like this, and then you could invoke it on your own. Let's say that you created this was your own service. This was not a hosted service, and you created my custom startup. Right? You absolutely could do this. And then inside of here, this is where you would register your event and all that, and that would probably work. But I caution against, just blazing your own path. Semicolon. When hosted services are here, use them. That's what they're for. They have all the logic already built in for start and stop. And there's just no reason to go and invent your own way to make it happen. Plus, this is using it like this, where you use hosted service, is a bit more self-documenting. You know exactly what you are expecting out of these services. You're expecting them to just be hosted and running in the background, either waiting or polling. Not just some class that you're unsure how it's being invoked or what have you. A couple of other notes. These hosted services running in the background means they are going to be created as singletons, and that means you are not going to be able to inject scoped services. So let's jump into one of these services. It doesn't matter which one. Let's say that this hosted service, we're going to get really, really not cool here, and we're going to create a repo right here. My repository, and this is the repository where we're going to write data, and we are going to inject this guy in, and when we receive our very important notification, here's where we would say my repository dot write, or add entity, and that would go and write it to the database. We're not going to write all that out, but we're going to inject it. Now, so we have this repository. It would have an interface. Don't judge me by this dirty code. We will come over and we'll register that repository. So we will builder.services, and we will add. So if we add it as a transient, then everything is going to be happy. Hosted service sidebar. I'm not loving this this new headerless file. I should just go ahead and convert it because it doesn't have the namespace and it just seems like a pain. But I'm going to stick with it for the rest of this since I'm already invested. So we can register this as a transient, and everything is going to work. So we registered as a transient. We will run our application, pull up our this and that, turn on our refresh, and we can see that everything is still working. Good. Everyone is happy. However, if we make this a scoped service instead of a transient, so if we make this scoped, this is not going to work because, well, singletons, unrelated to hosted services, singletons cannot receive injection of scoped services because singleton has no scope. So if we switch to this to scoped, immediately that service is going to fail. You see, it blew up right here already just because it couldn't inject that service. And so this is the reason that I would recommend using something like SignalR or Nlog. Again, don't want to get too far into that, but hook up Nlog or SignalR and then wrap all of this stuff in a try-catch and have your SignalR or Nlog write those logs of any errors that happen on startup for debugging. This video has already gotten a little bit out of control, so I am not going to go and wire all that up. But if I run this in debug, not what I would normally do, then I'm going to see that some services not able to be constructed, cannot consume a scoped service. So, as I said, you cannot inject a scoped service. So what if you have to get a scoped service in there? Well, I mean, you definitely can do it. So we're going to leave that. We're going to leave that as scoped. We are going to switch back over to our service that's using the scope service, and we're not going to be able to bring it in directly. But what we can do is we can bring our service provider in. So this, with this, it'll allow us to, one, create a scope, and then two, create our service. So we are going to bring this guy in. This one is gone, and we will. This won't be able to be read-only. We can't set it in the constructor, but what we can do is when our application our hosted service starts up, we can use our service provider to create a scope. But actually, since we're in the service that is just listening, we're not going to do it at startup because the scope will expire. Every time we receive our notification, we will create our scope. Our scope equals create a scope off of our service provider, and now with our scope we can create services. Service provider dot get service, because now we're accessing the service provider off of our scope. So now we can get our my repository, and we can say var repo equals. Now we'll have an instance of our repository. We won't be using this guy anymore, and with that we can create our repo. And let's also, so if this fails, then we won't get to this log, but we will, just for fun, we will also log that whether or not our repo is null. So let's go with if repo equals null, then boo, and otherwise, yay, we have a repo. Okay, so this should be good enough, because we would get an error here, but actually we won't, because we didn't do a required service. We just did get service, so it'll be happy. If it's not, we could do get required service, and then that will actually throw an error if we fail to get our repo. So now this line is really not useful, but we're going to leave it anyway. We're going to run this, and we are going to check our log, and we will invoke our very important notification. And there we go. So we have we've now injected a scoped service into our hosted service. Now, a bit of caution: scoped services are often scoped for a reason, and if you expect some kind of context around the scope, like for an API, if you're using JWT tokens, to know what user is accessing, none of that stuff's going to be available. So you need to be sure that using the scope service is okay. The flip side of that is, from what I see, almost everyone uses scope services no matter what, even if it should be transient. The default seems to be everyone use scope services. So it very well could be that you're injecting scope services that are only scoped because someone marked them scoped, not because they need to be scoped. And that's a good case for when you might do this. Now, for this, we're creating a scope for every event, every time this fires, but and that's because this guy is just listening. He's just sitting here waiting. We don't know when he's going to get his notifications. But if we wanted to do this in our polling application, because we have our loop here, we could do this just one time right here. We didn't inject our service provider, but we will. iService provider. So we'll inject that in. And now, of course, we're not using a repo here, but now when execute fires at the start of the application, our repo will get instantiated just one time. And then the whole time that we're polling, we will just continue to use that one instance of the repository. And maybe that's what you want, or maybe you want to put it inside. Maybe you want to put the scope inside of your loop and do it that way. But if you're concerned about creating a scope every time something happens, then you could use the background service and the polling technique to only create the service one time. It really depends on your individual use case. And after all of that, some of you might still be thinking, well, I'll just use Hangfire. Hangfire is amazing. So if you're not familiar with Hangfire, Hangfire is a third-party framework and application, really, that you can install and run inside of your .NET Framework or .NET Core application and lets you run background tasks. But it does way more than that. It provides a way for you to check the status of jobs, even a user interface for going in and seeing jobs, running jobs. So it provides a ton of functionality, but sometimes you just don't need all that. It requires a SQL Server database to manage all of its tables, and it just has a bunch of overhead that comes with it, that if you just need to do some simple tasks like this, maybe you don't need to go out and do Hangfire. There's different tiers of Hangfire as well, in terms of whether it's free or paid. So if you need an extremely robust solution with user interface for viewing jobs, running jobs, background tasks, absolutely go with Hangfire. But if you just need some services that you're comfortable writing the logic for, and you don't need a user interface for managing them, then just write your own hosted services. And it's pretty easy. As always, I appreciate you taking the time to watch this video, and I hope you have a wonderful day.